Hey class, Mr. H here. I'm going to pick up where we left off in chapter 6.1. This is page 4, arc length. So you, in some applications, want to find the arc length of a circle. We can manipulate that formula from radians to give us, and solve that for r, to give us a little formula. So it's pretty simple. It's just r times theta. The key is, and the important thing is, theta must be in radians. Don't use that formula if theta is in degrees. Everything falls apart. Okay, so theta in radians, otherwise it's pretty straightforward. Let's look at an example. You have a circle of radius 18.2. Find the length of the arc intercepted by an angle of 3 pi over 8. So there's a picture of it. We're trying to find S in that picture. That S is an arc length. So applying my formula, S is equal to R, which is 18.20. Let's just write it 18.2. And then times theta, which is 3 pi over 8. Now, is that in radians? Yes, because there's no degree symbol on it, and it has a pi in there. That's another clue, but there's not always a pi, but I know that's in radians. So all I gotta do is that in my calculator, and I'm good to go. So let me bring up my calculator, and we'll do it that way. Clear it out. Okay, so I'm putting in 18.2. And then I would just do this, times 3, hit your pi button, divided by 8, just like that, right? 18.2, I mean, it looks like what it's supposed to be. And then this one says round to 2 decimal places, so that's 21.44. Matches the radius, which was 2 decimal places, and that should be in centimeters, right? So it's the length of the arc, okay? So pretty fun. How about the next one, where this one, notice the angle is given in degrees. So we're gonna have to do an extra step on that. So how long is an arc intercept? How long is an arc intercepted by an angle of 120 in a circle of 11.23 feet, right? That should be radius. So let's include that in there. Sorry about that. This is a radius of 11.23. Okay. Sometimes you're given the diameter. So if it's the diameter all the way across the circle, you'd have to divide that by 2 to get the radius. But here, let's assume that's the radius. So typo. Okay. So first thing I got to do is take that 120 degrees and convert that to radians. Now you could use your handy dandy guide, because that one's pretty common. 120 is 2 pi over 3, right? So that works. Or if you forget that, you remember your technique is multiplied by 180 over pi. Pi over 180, right? And that's when you simplify it, 2 pi over 3, okay? And then now S is equal to R times theta, 11.23 times 2 pi over 3. And then that's going to be much the same way you typed in the last one. So I'm not going to bring up the calculator. I'm just going to do it. Sorry, my room's kind of dark. So I should do this in the light. Do your homework in the light. That's helpful. Okay, so this is 23.52. Okay. And that will be in feet because the radius was in feet. Okay, so those are fun. Here is a word problem that we have now, the latitude of Reno versus Los Angeles. And the picture sort of describes what we're looking at, right? Los Angeles is 34 degrees above the equator and Reno is 40 degrees above the equator. And if they're both approximately on the same longitude, then their distance can be found by arc length, right? So Reno is pretty much due north of Los Angeles. So notice the difference between 40 degrees and 34 degrees is 6 degrees. Right, so that's my central angle. And then I got to take that 6 degrees and multiply it by pi over 180. Now, if you can, I wouldn't get a decimal approximation just yet. Maybe leave this in exact form if possible. So this is pi over 30, right? Because 6 goes into 180 30 times, and just reducing. 6 into 180 goes 30. Okay, so let's leave that as pi over 30. And then now I'm going to bring out the formula. S is equal to r theta. Right? And then that's going to be r. Now I got to use the radius of the Earth. We're assuming that's 6,400 kilometers, and multiply that by pi over 30. Okay, and then now I'm going to do an approximation. This one, it didn't say what to round to. So if it doesn't, I got to just go with the significant digits. Looks like 2 significant digits there. That's what we're going to do. So I'm going to jump onto my calculator. I'll bring that one up just to show what I'm doing. I'm doing 6,400 times pi over 30. Okay, and that's 670, right? So that's approximately 670, and that would be 2 significant digits. So I'm good with that, right? And that would be in kilometers. Okay, so pretty cool application of arc length is finding the distance between 2 objects on a circle, like the Earth. Okay, last type of problem we're going to look at. Sorry, let's show you my work there. 670 verified. Okay, next one, area of a sector. So now we're talking about like the piece of a pie. A sector is a portion, that red shaded area. Okay, that one has a little formula, right? Half r squared times pi has to do with the area of a circle with a fraction thereof, right? So again, theta must be in radians, important. Don't use these formulas unless theta is in radians. Okay, so this example, I have my central angle is 15. Anytime you see anything in degrees, you don't even have to read the problem yet. Just convert it to radians. Right? And try to leave it in exact form if at all possible. Right? So, I mean, you could just, you don't even have to reduce it. You could just leave this 15 pi over 180, right? I mean, who cares about reducing right now? It's not a final answer or anything. You could reduce it, but I don't want to waste my time doing that. I don't have to. Okay, and now I'm going to apply the formula. So it's area equals, so I'm using this guy up here, 1/2 r is 321, right, squared. And then the theta is 15 pi over 180. Okay, now how should we put that into our calculator? Well, I would do it all at once, like this. So 1/2, I just would use 0.5, because that's easier to type in, right? So I mean, I could do 1 divided by 2, but I just know that's 0.5, right? So 0.5 times 321, and then you can hit your x squared button, square it, right? Times 15 times pi divided by 180. And then enter it. Okay. And there's my answer. This one said round to the nearest integer, so I would just use the whole number, 13,488. Right? And then the unit of measurement for this one would be meters squared, or square meters, because we're finding an area, right? An area is always measured in square units of measurement. Okay, so does that look good? Check my work. I think I entered everything in right. Okay, I'm going to go with that as the correct final answer. I'm sure I'll hear from you if it's wrong. Okay, so I'll show you what I've put on my handout. And we are good here, okay? So those problems aren't too bad. Stick to the formula. Make sure you're putting in radians. Use your calculator, and all life is good. Okay, hope all's well. Talk to you later. That's the end of 6.1. Woohoo.